Okay, I'm going to go through the revision test today so that once you've had a go at it, you can check your answers. Make sure you do have a go at it first, otherwise you're not really learning everything if you watch it directly, unless you're absolutely unsure on how to do something, in which case watching it might be a good move. Okay, question number 1. Let's get started. Name these 3 elements. The nucleus, you'll notice, isn't shown, just the electrons. The first element has got 2 and then 8, so that means, and then a third shell, so that means it must be in the third row of the periodic table, and it's got 3 in the outer shell, so on the third row of the periodic table, that will probably make it aluminium. 3 in the outer shell, there we go, that's aluminium. I'll get that written down. Aluminium. Next one over here, let's go and have a look. It's now got 1, 2, 3, 4, 5, 6, 7 in the outer shell of the third shell, so that's the third row of the periodic table, so it's got to be chlorine. Oops. And the last element has only got 1 electron, but it's in the outer shell, but it's got 3 shells, so that makes it sodium. Ignore the colour change, I wasn't concentrating what I was doing. Alright, let's go to question number 2. Let's go up a bit, move yourself, there we go, up a bit. Alright, now we have to draw these elements. Well, before we start drawing these elements, let's go and put things down. Helium has a Z, if you look at your periodic table, which is the atomic number of 2. So the second element has got an A of equal to, if I'm rounding it to the nearest whole number, 4. Let's go and have a look at magnesium. Magnesium has got a Z of 12 and an A of 24. And carbon has a Z of 6 and an A of 12. Again, I'm reading from the periodic table, rounding the A's to the nearest whole number. Alright. So, let's start off with helium. That tells me that in the nucleus I've definitely got 2 protons. The A tells me I also have 2 neutrons in the nucleus to make up my 4. That's the nucleus. And there's 2 electrons outside the nucleus, and if I'm drawing them in shells, then they'll form one shell, but you aren't necessarily working with shells in grade 9. Okay, so that's the nucleus. Might label that as the nucleus, so we know that means the nucleus. Okay, magnesium has this is a Z of 12, so and an A of 24, so that means 12 little pluses, plus, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and must have circles 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 protons, 12 neutrons, and it's therefore got 12 electrons. If you want to draw them as shells, it's actually got 2 electrons in the first shell, then 8 more. So that's the first shell. If you're not interested in shells, you can just scatter them anywhere. 1 to 8 in the next one. That means we're now up to 10. Got 12 more. We'll pop the last 2 in the last shell, and a couple more out there in the last shell. And then finally we get to carbon. Carbon has got do the nucleus of carbon, there'll be 6 pluses, 6 protons, 1, 2, 3, 4, 5, 6, 6 neutrons. 1, 2, 3, 4, 5, 6. Again, draw it better than I do, and there'll be 6 electrons, 2 in the first shell. If you're doing it with shells, you don't have to do it with shells as long as you get the number right. That's more a grade 10 thing, and then 4 in the next shell, giving me 6. 1, 2, 3, 4. Sorry, only 4 in the next shell, because the 2 and the 4 make 6, so that's all done now. Okay. Again, drawing elements in the periodic table, I'll leave you to choose your sequence. One easy way would have been to have started with hydrogen and helium and lithium, because they're the 3 easiest elements. If you want to test yourself more, then you might do a row like silicon, phosphorus and sulfur, which would have many more protons and electrons in. Okay, now we move to the next page. Hopefully we know that this is water. The next one over here, we haven't spent a lot of time looking at this year. We call it methane. But if you were to write something like carbon hydride, we wouldn't necessarily mark it wrong. But its official name is methane. So if we're drawing a diagram, we need to go and think back to our various models. So for instance, if we have water, then we have oxygen in the middle. Remember this when you're doing the diagrams, and then it's joined to a couple of hydrogens like that. Methane has got a carbon in the middle, and it's joined to 4, 1, 2, 3, and the sort of fourth one going into the page. All these ones come slightly out of the page. It's joined to 4 hydrogens. A bit hard to draw when you've only got 2 dimensions. I'm trying to show with the dotted line here that this is going into the page, and the other 3 coming out of the page very slightly. It's hard to draw something that's 3-dimensional on a flat bit of paper. Okay, let's go down to the last question. Circle the correct answer, a precipitate. Hopefully we know that it's a solid floating around. And finally, if you had a precipitate in a test tube, how would you separate it from the rest of the liquid? You would basically use filter paper and a funnel. Remember how we did that? So once you made your precipitate, and you'll get to do this a bit later on, you'd basically have some kind of flask, and you put your funnel in your flask and your filter paper on the funnel, and the precipitate would go there, precipitate would collect here, now we have a word for the liquid that goes through, and the liquid that goes through we call the filtrate. So the filtrate is the stuff that the filter paper doesn't block. Okay, that's the foundation test done.